Good morning and welcome everybody to today's webinar on the topic of the EOR-1DS, our economical and short circuit and earth fault indicator for the future-proof local network station. I would start with a few sentences about myself. My name is Jonathan Frey. I work at EORSys, which is the product group that developed and supports the EOR-1DS as an application engineer, and I started doing so in September of last year. Well, as an application engineer, I started working at EORSys about 3 years ago as a working student, and I also wrote my bachelor's thesis for EORSys. That was about a new earth fault location algorithm that is not yet in our devices, but maybe in the future. Yeah, so let's start with the webinar. Didn't react, no. Yeah, a few sentences about the company. Eberle has 44 years of experience in measurement and regulation technology. It was founded in 1980 and is now located at the Franken campus in Nuremberg. This is our headquarter, but Eberle has subdivisions all over the world. As it says here, operating internationally in approximately 65 countries. Not each of these countries has a subdivision. Some are our partners. But Eberle operates internationally. As of right now, there are 150 employees working for the company. As it says here, dedicated to the corporate mission of clarity, openness, and fairness. The company is steadily growing. So when I started in August 2022, there were about 100 employees, and 3 years later, 150. And the company is active at all voltage levels, so high, medium, and low voltage, and also production, transport, and distribution of electrical energy. It was repeatedly awarded and certified. As you see here, a few certifications and top innovator, German top innovator, many consecutive years, few years break, and then last consecutive years. Also Kununu top company. Yeah, here you see an overview of our of all of our devices for each of the product groups, and also sorted by. I'm sorry, something is up with the skip button, and also sorted by voltage level. In the top row, you have power quality, mobile, and fix. That are both active at low, medium, and high voltage. Then in the middle row, there's voltage regulation. As you see, two different product groups as well. One for the low voltage regulation that is quite new. This product group is one of the younger ones. And the other voltage regulation product group for medium and high voltage regulation has the REC-D, which is the product that Eberle first developed. And lastly, in the bottom rows, there is earth fault compensation and detection, which is done by our product group, EOR-Sys. And we have earth fault location devices, the EOR-1DS and the see here, that are mostly used in medium voltage levels. And also the Patterson coil regulator, REC-DP, with its variation REC-DPA, and a few variations of current injection. Here you see the MCI. The Patterson coil regulator is used in a compensated grid to regulate the Patterson coil in order to have minimal or a set point of fault current in case of an earth fault. And our earth fault detection devices are also, of course, earth fault and short circuit oriented. Today's agenda will be first, we are going to talk about the differences between simple and digital and remotely signaled and remotely controlled secondary substations, all with the main focus on the intelligent grid. Then I'm going to give you an overview of the measuring hardware of the EOR-1DS, also the location procedure inside the EOR-1DS, only a short overview. Normally the presentation on this topic alone is about 1 day, so yeah, a really short overview of the location procedure. Then EOR-1DS display, operation and parameterization, so all the key features for commissioning. And then lastly, the possible combination of the EOR-1DS with our EOR-3DS or the PQI-LV from our power quality sector. So yeah, let's start with the difference between a simple and a digital or remotely signaled and remote controlled secondary substation. Yeah, why would you need to invest in an active and automated network operations? Here you see the statutory targets for the energy transition that are defined in the Renewable Energy Law of 2024. Of course, these are the goals that are only true for Germany, but the transition to renewable electrical energy is something that is important worldwide. So the goals are to have at least 80% of electricity in Germany to be generated from renewable energies by 2030. And as of right now, that is about 60%, so a growth of about 1/3. Then also, they plan to install 115 gigawatts of onshore and 30 gigawatts of offshore wind power. And this would be about twice the current amount. And photovoltaic energy is expected to triple to about 215 gigawatts. So as it shows here, nearly all of electrical energy production is going to change dramatically, or they plan on it to change dramatically in the next 5 years. And in order to handle this as a grid operator, you will need to manage your grid intelligently. 1 second. It was estimated by grid operators that are in a development partnership with us that you would need about 10 to 20% of your local network stations to be digital, and about 80 to 90% of your local network stations to be simple in order to achieve a sufficiently intelligent grid. Of course, from a technical point of view, 100% intelligent or digital local network stations would be perfect, but there's also the economical factor to be considered. Something I forgot to mention in the beginning, if there are any questions regarding any of these topics, not only specifically for the EOR-1DS, feel free to use the chat, and then we will answer every question after the webinar is finished or in the end of the webinar. So yeah, no question stays unanswered. The key features of the digital local network stations are that they are remotely reported. This means that all the measurement values and the status diagnosis is digitized inside the station, and then your control center receives precise measured values of the station. Also, these stations are or should be remote controlled. This means that you can remote control and signal your load breaking switch, including the outgoing earthing switch. And that way you can have remote switching operations and control which feeders are connected to which substations. The typicals for these stations are also customized parameterization and design for scaling, especially with a focus on personnel costs. you would need hundreds of these stations with many devices inside of each station. So yeah, they should be beforehand designed for scaling. And one of these scaling points is remote updates. So it should be possible to perform fleet firmware and parameter updates for functional enhancements, again with the focus on personnel costs to be reduced. Yeah, as I said before, from a technical point of view, 100% digital local network stations would be perfect, but from an economical point of view, 10 to 20% are sufficient, and the rest would be simple local network stations. The features of these stations are that on average, you have one station per 100 customers installed in the network. These stations do not have communication connections. They are not remote controlled and only manually adjustable. And that means that service personnel has to be on site to adjust settings or to evaluate earth fault or short circuit location. For the simple secondary substation, our main solution is the EOR-1DS. As you can see here in this version, including Rogowski sensors or low power sensor inputs. For the main or key secondary substations, so the digital substation or your primary substation, we would also offer the EOR-3DS, but yeah, that's not a topic today. The requirements for simple earth fault and short circuit indicators are that you should have they should have a simple and clear display for on-site personnel. They should be simple to be. They should be installed simply, and also the parameterization should be simple in order to reduce installation costs. They should be able to be used flexibly for different measuring hardware, and of course have high reliability in location or fault localization. That is still the main focus of our devices, of course. And also these devices should be expandable and future-proof. Here you see a simplified a simplified grid with two digital substations or two intelligent substations that both have an EOR-3DS or multiple EOR-3DS inside them. And in between these bigger substations, there are your simple or non-intelligent substations. And then when a fault occurs, both of your digital substations or the EOR-3DS inside of them will point into the fault direction. But as you see here, this information is not sufficient to precisely locate the fault. You only see that it would be in this area or this section. That's why the installation of additional devices at important nodes of your grid is helpful for fault localization. And as you can see here, you have a few EOR-1DS installed inside of these simple stations, and then they all point into the fault direction. And that way, it's really easy to precisely locate the fault. Let's now get into the overview of the EOR-1DS measuring hardware. As mentioned before, one of the requirements for a simple earth fault and short circuit indicator would be the flexible use for different measuring hardware. And that's why we offer such a broad variation inside the measuring hardware combinations of the EOR-1DS. We have three key examples here, but of course combinations of these examples are possible. So if you have any detailed questions, just put them into the chat and we will answer them later. Example number one would be that you have a station without transformers available, so no voltage or current transformer. You have a capacitive voltage testing system installed that is installed anyways for personal safety. As you can see here, you have these voltage indicators. for each phase. You also do have a simple termination without a tapping option. So you can't tap your termination for measurement, and you do not have remote SCADA connection. And in this station, your objective would be retrofitting of earth fault and short circuit detection without the measurement value transmission. For this, the simple cost-effective retrofit solution of the EOR-1DS would be these Rogowski current measurements and capacitive voltage measurement using an LRM cable, or just one of these options. As you can see here, you can choose the option of a non-directional fault display. For this, you would only need current measurement. For example, these 3 Rogowski coils or Rogowski sensors, and that way you would still be able to perform earth visualization using the pulse location method, or you can have short circuit indication, but that would be non-directional, as it says here. If you do want directional fault indication, you would need voltage and current measurement. For example, here in parallel with a voltage testing system. But the disadvantage of using this retrofit solution is that it is not suitable for all locating methods, as this measurement is not sufficiently accurate. But it really depends on your localization method that you want to use, and of course on temperature and aging of your sensors. This is mainly used as a retrofit solution because you do not have to perform additional installation, and it's really easy to install it as a retrofit, as you can see here. Example number 2 would be that you do have current and voltage transformers installed, or you're able to install them, and you do have remote SCADA connection. And your objective would be, in this case, to have earth fault and short circuit detection with measured value transmission. For this option, we offer additional adapters for the classical measurement values. As you can see here in these 2 pictures, there is a current transformer for 1 or 5 amps nominal current with the C21 or C25 adapter. The only difference between these 2 is that one measures all the phase currents and the 0 sequence current, and the other one measures only the 0 sequence current. And then you have a voltage transformer as well with a nominal voltage of 100 or 110 volts AC with our U10 adapter. Both of these adapters are available for DIN rail mount, as you can see here, or for panel mounting, as you can see in this picture. And they are also they can also be used in a modular combined voltage and current adapter as a plug-on adapter. See here, or this one is also combined adapter of the both. This is a really cost-effective replacement of transient relays like the Eberle EWR-22 transient relay. This is one of our really old earth fault indicators. And with this combination, you can use various locating methods depending on transformer accuracy. But I will get to the location methods later. The third example would be that you do not have transformers available, so no voltage and current measurement already installed, but you do have a termination with a T connector, and also you have high demands for measurement accuracy. The objective would again be to have earth fault and short circuit detection with in-depth location and measurement value transmission. And for this option, you have the most precise measurement option. You have these highly precise power measurement with the low power sensors. And for this, the EOR-1DS is compatible with a variety of sensor manufacturers. Sorry. For example, Cisco, 3M, ABB, but also other manufacturers as well. Yeah, and then this way it's possible to have phase and RMS values for active, reactive, and apparent power on site or transmitted via Modbus RTU, and also precise voltage, current, and power measurement with these class 0.5 low power sensors. Yeah, so really high measurement accuracy. Which brings us to our next main topic, that is EOR-1DS location procedure. Yeah, here you see a typical location process in a compensated grid, but this would also work in an isolated grid. The only difference would be that your stationary procedure would use different localization methods, but in general, the same two steps. So at first you have the transient earth fault location with our QU2 algorithm. And this algorithm evaluates the transient process during an earth fault. It has really low demands towards measurement accuracy and works reliable no matter your grid structure. So in rings and mesh grids, and of course also in single line operation. And it has a very fast direction indication. But the main disadvantage of the transient location is that you do not have relocation, do not have the possibility of relocation. So when you perform switching operations to further single out the faulty segments, then your transient method will not help you. That's why you will need stationary procedure. For example, the watt metric method or the pulse location. The watt metric method or cosine phi method does have high demands towards measurement accuracy. No matter if you use transducers or sensors. So for both voltage and current measurement, high demands. It only works in single line operation, and it has this post location option for in-depth location. Or you could also use the pulse location. Of course, for this you would need the possibility to send a pulse through your grid. But for this, if you do have this possibility, then for the pulse location, you will only need current measurement inside your station. It only works in single line operation as well. You do have the post location option since it's a stationary procedure, and again, depth location is possible. So this fulfills the requirement of high reliability in localization. And as you can see here, the last slide was just an example. The EOR-1DS does have a few more localization methods. So in the compensated grid, that would be the QU2 algorithm, the watt metric method, and the pulse location, as I said before, and of course, short circuit detection as well. In an isolated grid, you would have the QU2 algorithm as well, and also your reactive current method, the sine phi method. This method does not have such high requirements for measurement accuracy. So in an isolated grid, the requirements for measurement accuracy are lower than in a compensated grid. And you have short circuit detection as well. And in the grounded grid, you only have short circuit detection since the earth fault would be a short circuit as well. And in this table here, you see an overview of which localization method would be viable depending on the measurement that you use inside your station and depending on the measurement accuracy, as you can see here. Only the cosine method or the watt metric method has specific needs for measurement accuracy. The other ones do not, but depending on the combination of current and voltage measurement, it may or may not be possible to use the localization method of your choice. So then let's get into the EOR-1DS display, operation, and parameterization. Again, one of the features that was mentioned would be that the EOR-1DS should have any simple earth fault and short circuit indicator should have a simple and clear display for on-site personnel. The indication on the EOR-1DS has three main paths. One is the external indication. So you can connect a blinking light of two different types to your device, and you can install the blinking light outside your station, and that way your technician would only need to drive from station to station and not enter the station in order to precisely detect the fault location. And then once inside the station, you also have the display indication. As you can see here, a few examples. So this would be an earth fault in feeder direction. The arrow that points downwards is always in feeder direction because the feeder goes down into the ground. And as you see here, feeder 3 does have the connection to the earth symbol. Then when you do not have voltage measurement, you only have a general earth fault earth fault directional indication and not a phase specific earth fault indication. So here you would have a earth fault in forward direction or feeder direction without the information about which one is the faulty phase. Here you see a short circuit indication on phase 1 and 2, and this one is a short circuit indication in feeder direction as well on all of the three phases. But it's also possible to use remote indication. That could be done via a relay contact. The EOR-1DS has 4 relays, but it's also possible to use Modbus RTU and then connect it to your SCADA converter to use another protocol to reach your control center. Or you could also use a EOR-3DS for this. And this device would also be able to convert from Modbus RTU to an IEC protocol. The display also offers a few other views. One would be measurement data, as you see here, voltage, current for each of the phases. Also reactive power or your total powers. So here's active power, sorry, or your total powers. So active, reactive, and apparent power. Also your frequency measurement. So all your measurement data. Then also system information. So the status of each of the phases. Also which localization methods are in use and what are the relays that they indicate to. You have the overview of the set frequency. So not your measured frequency, but the frequency that you tell the device is the nominal frequency of the grid. Your firmware version and hardware version information. Also date, time, so a few system information pages. And lastly, you have menu and settings where you can perform settings. Few examples would be to parameterize the QU2 method in this example, or set a threshold for short circuit indication, or change the device's code. You can put in a passcode for your device so that it can only be parameterized by someone who enters this passcode. So as you can see here, the display offers a variety of information slides while being really, really simple. Next point would be simple installation and parameterization. As mentioned before, the most simple and most cost-effective retrofit solution or installation option of the EOR-1DS would be the retrofit solution. yeah, with the current measurement via Rogowski sensors and the voltage tab. The other simple installation features of the EOR-1DS are that you have a wide range power supply of yeah, DC and AC power supply, and yeah, wide range in voltage. So that way you can install it in all of your stations and do not have to order a specific variant of the EOR-1DS for each specific station or each type of station. Yeah, you have the current measurement via Rogowski sensors and voltage measurement, for example, in parallel with the capacitive voltage measurement. And the connection would be done using these push-in terminals. They are also quite easy to handle. Yeah, as it says in the name, you just push in the connector and then it's installed. The parameterization and firmware updates as well are also really easy and intuitive. It's completely the complete setup is done using the rotary knob in the front of the device, so you do not have parameterization software. And after parameterizing one of the devices, then you save the parameter set on your SD card, then remove the front panel, exert the SD card, insert it into another device, and then simply load the parameters from the SD card and maybe only adjust sensor factors or adjust nothing at all, depending on the situation, of course. Yeah, so really easy parameterization and installation, and firmware update is done the same. Yeah, it's also possible that we do the parameterization for you, either on site or we do it here, and then you get the devices with a customer-specific parameterization already on your device when it arrives. For fault analysis, the EOR-1DS also has an integrated SD card. So you do have fault records with adjustable recording length saved on your SD card. You have a logbook as well. And as I said before, you can save your parameter settings on the SD card. Yeah, and then afterwards you can analyze your fault records and your logbook using, for example, the Eberle toolbox, which is the free parameterization software of the EOR-3DS, but also of other devices. The EOR-1DS also grants availability of indication in the event of a power failure, and this is done by, because there is a long life capacitor or a supercap battery. This is done simply because there is no or really reduced maintenance of the device. You don't have to change a battery, or you do not have to change a capacitor nearly as often as a battery. And this way we guarantee that you have indicator operation for at least 4 hours, even after 15 years of installation, and even when using the blinking lights. The indication via Modbus RTU is not available for 4 hours, but it's selectable for a follow-up time. Standard would be 30 seconds after supply voltage failure. So then let's get to the last topic of today, the possible combination of the EOR-1DS with the EOR-3DS or the PQI-LV. This combination could be done to simply have a remote SCADA connection, or also to have a Modbus master-slave system. As you can see here, the EOR-3DS would function as a Modbus master, while the EOR-1DS, or it could be EOR-3DS as well, yeah, but while the EOR-1DS functions as a Modbus slave, they communicate via Modbus RTU, and then the EOR-3DS will convert this and transfer the data via an IEC protocol or DNP3 or Goose. Yeah, you do have a few SCADA protocols available. Yeah, you see the possible protocols here. Yeah, as mentioned before, it's not limited to EOR-3DS 1DS combination. You can also have additional non-Eberle devices inside your Modbus master slave system. And you're also able to use several protocols in parallel when communicating with your control center. And then the EOR-3DS is a SCADA gateway. And here you see all the possible protocols of the EOR-3DS. So you have Modbus, RTU, TCP, you have the IEC 103, 101, 104, DNP3, serial, and via TCP. Also 61850 Goose, or MQTT management and operations, or MQTT IoT, which are the main SCADA protocols for the intelligent secondary substation. The other option for the installation inside a digital or intelligent secondary substation would be combining the EOR-1DS with the PQI-LV. In this case, you would have an EOR-3DS installed at each feeder, while the PQI-LV measures the transformer and also the different lines to each of your households or each of your electricity customers. This would be a medium voltage application as well. So you have state estimation that is made possible by high precision measurement technology in these medium voltage grids. And of course, also directional detection of and indication of earth fault, EOR-1DS. And then on the low voltage side, you have the PQI-LV that has power quality and fault recording possible with also with the retrofit sensor technology. It has an RTU data logger and measurement data acquisition. Yeah, that has to be in Germany. It's of course another law than it would be in your country, but you probably do have the obligation to have grid status determination as well. The PQI-LV would be monitored and parameterized using the WebPQ software. And with this software, you can monitor the substation, you can achieve or archive or report your data. You have patch and device management and fleet management. But if there are any specific questions regarding the PQI-LV, I would have to answer these questions afterwards. So not in the end of this webinar, since I'm not that firm with the PQI-LV or any PQ devices. Yeah, so we are now nearly done with the webinar, and that's why I want to give you a short last overview of the EOR-1DS. So yeah, it is basically a economical short circuit and earth fault indicator for a future-proof local network station. It offers a simple and clear display it has a direct and clear display on the device and also offers the external flashing lights. It is flexible in use for different measurement hardware. So you can have measurement via capacitive taps and Rogowski coils, or also the classic measurement. But you do also have the option of measurement with highly precise low power current and voltage sensors. The EOR-1DS also grants high reliability in location. It supports the transient method as well as stationary location procedures, and also offers fault record analysis and a logbook. Give me 1 second, my throat is really dry. Another key feature of the EOR-1DS is the simple installation and parameterization, with the main focus of on reducing installation costs. It has a wide range power supply unit. Yeah, mentioned before, DC and AC, wide voltage range. It has these push-in terminals for easy installation, the parameter transfer via the SD card, and also the option of pre-parameterization on delivery that is done by us. And it's also it's also expandable and future-proof, especially because of the options of connecting it via Modbus RTU to a EOR-3DS or PQI device. And this combination enables remote SCADA connection of the EOR-1DS as well via IEC protocols. Yeah, so that would be it for today. Of course, I will answer your questions afterwards. Thank you very much for your attention. And then I would ask my colleague Max if there are any questions in the chat. All right, yeah, thank you everybody for your attention. And yeah, I hope that this webinar was helpful to you.